Hi, hello everybody. So this is the video about section 9.3, the parabola, and this is the second part of the section dealing with parabolas not centered at the origin. So in the previous section, we've covered the standard form of the parabola, which is a special curve that has equal distance from the focus to the parabola and from the parabola to the directrix. So that gives it a special type of an equation. And we've covered those equations were centered at the origin. Now, for equations whose vertex is not at the origin, we call those, as you can see here, translations of the parabolas. So this is just a fancy name to say that the parabola so here's the origin, for example. Imagine that you have a parabola that looks like this, right? So here's the x-axis, here's the y, and then you either gonna shift right, or gonna shift left, or gonna shift down, or gonna shift up. So we call it a translation. We've seen it before with other curves. It's it's just a standard shift in one of the four basic directions. Now, these are probably, once you know the basic format of the parabola, these are pretty easy because all that we have to do is shift the x position by either a plus value or a negative value, meaning I'm going to either go right or left, or I'm going to shift the y position either up or down, depending on the situation. Okay? So the equation now becomes, instead of having just y equals 4px or x squared equals 4py, we have this minus k and minus h here, or minus h and minus k. Okay. Yes, it seems a little scary, but I assure you it's not. And I'm going to give you an easy way uh, to find the vertex. All right, so for example, in this case, this is the vertex. And remember, the distance from the vertex to the focus is P. The distance from the vertex to the directrix is P. Okay, so once we find the vertex, then we can find the focus very easily and we can find the directrix. Now, so remember, for the purposes of questions that you're going to see on the exam, all that we have to do is put the equation in standard form. We don't need to graph. Put the equation in standard form. We need to find the vertex. We need to find the focus. And we need to find the directrix. Okay, that's it. These are the four things that we need to do. I'm not going to ask you to graph. Once you've done that, you're finished with the problem. Okay, so let me show you the problems that we're going to see. There are two types of problems here where we have to find those quantities. The first type of problem is the equation is already in some form of the basic, or it is in the basic format, like these two that you see over here. So we're going to work these two first, and then I'm going to show you the other type where we have to do a little bit more work. Okay, so let's do the first one first. This is example 4 in the textbook. So again, example 4 and example 5, you can go back and check. All right, so let's do these two problems. So again, yes, it would be nice if you could see the equation. Oops. It is rather small. Let's see. I hope you can see this. Uh, Take a look at the equation. So here is one, and here's the other. The only thing difference is it's just like a circle. You remember seeing the circle. It's not centered at the origin. That's all. So 8y plus 1. Now, this is already in standard form. So the very first thing that we need to do is we needed to identify if we have a parabola that opens up or down right or left. Because I have an x square component, right? So here's the x and here's the square. I have this scenario. This is the standard parabola, up or down. All right. So I have an up or down parabola. And what am I going to do again? I need to factor this 8. I need to factor out 4 out. So I'm going to write x minus 3 square, 4, obviously 2, y plus 1. Right? So when you pull a 4 out, and the p is going to be this number divided by 4. So my p equals to 2, which is positive, which means this parabola is going to open upward. Okay? So this is the standard form of the equation. Okay? Now, what is the vertex? Now, the vertex is incredibly easy. All you have to do, so you need a value for x and a value for y. The x value is this value with the opposite sign. So -3, +3. The y value is the opposite sign of this number. +1, -1. And we do this to get us back to the origin, right? So that's why it's the opposite. It's a shift up or down, right or left. So the vertex is at I'm sorry, 3, -1. Already got the vertex. Now, if you want, you can do a picture for you to find the focus and the directrix. It's not necessary, but I can show you one time here. So let's position your vertex 3, -1. So x3, -1 is here somewhere. This parabola is going to open up. Okay, so let's imagine that it does this. Here is my 3, -1. Here's my vertex. Now, remember what I said. The focus goes into the parabola somewhere, and the directrix goes the opposite way. Now, how far does it go? P units. This is my P. Okay. Wow. Absolute value P. In this case, P is 2, so it's the same. Now, I'm going to find the directrix because the directrix is in opposite where the parabola opens. So the directrix is going to be here. Okay, so this is my directrix. And in this case, it's going to have equation y equals, right? If it's parallel to the x, y. If it's parallel to the y, x equals. Now, this distance is p units. So if my p is 2 and I am at -1, right? P units down would be -3, right? I'm on the y equals -1. Going down 2 units, I get to -3. So for the focus, is the same thing. I am at -1 for the y, and I go 2 units up. 2 units up, so -1 plus 2, 1. So this is my focus. So my focus is at 3, same x coordinate, and position 1, y coordinate 1. So all that you would have to, I don't need to see this picture, obviously. So focus, you would write focus 3, 1, directrix. Now you have to, don't say just -3. This is incorrect. You have to say an equation. It's the equation, right? Y equals -3. And that's that first example. Now let's take a look at the other one that is similar to this one down here. This one right here, right? Very, very similar, in fact, identical, except that the parabola is going to open a different way. So y plus 3 square equals minus 8 minus 2. All right, so the parabola is almost in the standard form. The only thing I need to do is factor a form 4 out of here. So 4, and then obviously in here, negative 2, x minus 2. So obviously this is my p. P equals the absolute value of p is 2, but in this case, p is negative. So this is the parabola that I have a y square. So take a look up here. This is the case that I have. It's either going to open right or left. And because p is negative, this parabola is going to open left. Okay. Now, let's find the vertex. The vertex again it's gonna have two coordinates, x and y. And all that you do is pick the values. So here is my x, opposite value, right? If it's negative 2, x is 2. Here's my y. If it's positive 3, negative 3. So my vertex is at 2, negative 3. Okay. Now, again, if you need a picture to position yourself, uh, x is 2. Y is negative 3. Again, same location, almost same location as before. 2, negative 3. This is my vertex. The parabola is going to open left. So yeah, let's just do this. Parabola is going to open left. Now, my focus is going to be inside here somewhere, and my directrix is going to be here somewhere. Okay? Now, because the directrix is perpendicular, or I'm sorry, parallel to the y-axis, the equation is going to be x equals something. Now, the vertex, I'm going to position the vertex, which is 2, negative 3. My p-value is 2 units. So it's 2 units to the right, 2 units to the left. So this distance is 2 units. This distance is 2 units. So if I am located at my vertex is at 2, negative 3, 2 units to the right would be, right, x equals 4. So my directrix has equation x equals 4. Don't just write 4. You have to write the equation, which is x equals 4. And my focus is going to be, again, 2 units to the left of this value. Obviously, that would be 2 minus 2, 0, right? So my picture is a little bit off. So the focus is going to be right here at 0, negative 3. 0, negative 3. So here it is. The standard form of the parabola, the vertex, the directrix, and the focus. Okay, that's all you need to do. It takes a little bit of getting used to it, but once you position yourself at the vertex, then it's a lot easier to find the focus because it's p units into the parabola, and to find the directrix because it's p units away from the parabola. P units in bad absolute value, right? In distance points. Okay, so now let's do the other type of problem that you might get. And I would say that those are more important, but it's nothing new because we've seen this technique when we dealt with circles. Okay, so here's the equation, and notice the equation is not really nearly similar to the standard form as you see right here. Okay? So we have to, the very first thing that we have to do is have to go back to this format. And we do that by completing the square. The completing the square part is going to be done just like you did it on circles. It's going to be done on the variable that has the square. Okay? The variable that does not have the square is going to go to the other side of the equation. So in this case, the y component has the square. So the very first thing I'm going to do is I'm going to subtract 12x and I'm going to add 23 to both sides of the equation, because that has to go to the other side so that I can start putting in standard form. So this is out. I have y squared plus 2y equals minus 12x plus 23. Now I have to complete the square on the left side. So you remember my technique is same variable, same sign, half of this number, square. And then we have to do the adjustment. The adjustment is this number squared. So 1 square is 1. So I add 1 to the other side. This is always going to be positive. Even if the term was y minus 1 squared is still positive 1, and goes to the other side. Obviously, minus 1 squared, right? That's what you're doing. Okay. Now, the left side of the equation is done. And 23 plus 124, so I have this. I have to factor a GCF out of here. So you factor the GCF first. Don't try to factor 4 because it gets too complicated. So y plus 1 squared, and I can factor a minus 12, and I have x minus 2. Now I am back to something that resembles something like this, right? So now you go and now you factor a 4 out of this thing. Obviously, I get minus 3 here, and I get x minus 2. Perfect. So this is already the equation in standard form. So if you get an equation like this, you have to do all of this work, which is not that bad because it's the same technique as we've seen with the circle, and put it in standard form. From here, the process is the same as before. Okay? Now I'm going to erase this part right here because I need the space and I don't want to scroll down. So I'm going to erase this. And I'll do the work up here. So I know that I have to identify this equation now. This is the one that have the the y square, which is this format. So this parabola is going to open right or left. My p is -3, which is less than 0. So this is going to open left. All right. Now I have to find the vertex. And you already know the vertex is going to have coordinates x and y. And it's the opposite value of the x coordinate. So if it's -2, +2, and it's the opposite coordinate of the y, +1, -1. So here's my vertex. All right. If I want to, I will draw a curve so I can have a visual on everything. So x is 2. Again, in the, seems like everything is in the second quadrant, in the fourth quadrant. So here's 2, -1. And this thing is going to open left again, like I said. And my p-value is -3, but in absolute terms, it's +3. So I am 3 units this way for the directrix and 3 units going in here for the focus. So this is 3 units, right? So if my X is at 2, 3 units to the right would be X equals 5. All right. And 3 units to the left from 2, my focus would be here. And 2 minus 3, it would be X equals -1. So this will be -1, -1. Okay, I think I wrote it on the axis, but so let me do it so that you don't get confused. So 2, -1. The curve opens down. This is 2, -1. Here's my directrix, 3 units away. So this is X equals 5. And the focus is going into this direction, 3 units smaller than this in the X direction. So this is -1, -1. So here's my focus. Okay. So I have the vertex. I have the focus. And I have the directrix, which is X equals 5. All right, so let's do the last problem, which is this one down here. Same as the one before where we have to complete the square. So obviously, if you're taking notes along the video, you may have to stop every so often. Minus 2x plus 16y plus 49 equals 0. So again, this is not in standard form. I'm going to have to complete the square. So you're going to look for the x square component or y square component. In this case, it's x. So everything that's not x has to go to the other side. So I'm going to subtract. I'm going to begin by subtracting 16y, subtract 49y on both sides. All right, obviously here they cancel, and I am left with this. Minus 16y minus 49. And then I'm going to complete the square on the x or y square component. In this case, x squared. So x, same sign, half of this square equals whatever you have on the left side, on the right side, and then the -1 square, which is in this case 1, again, goes to the other side. Always to the other side to counterbalance, right? You are adding this quantity on the left side. You need to do the same thing on the left, on the right. So now I am going to my work on the left side is done. I'm going to simplify the right side. And then you're going to factor the GCF out of the right completely. Don't try to pull a 4 first. So minus 16 x, oops. I'm sorry, minus 16 y minus 3. Now, this is the equation in standard form, which we need to get. We just have to pull out the 4. So 4 minus 4 y minus 3. So this is the equation in standard form. So part of 1 done. My p is less than 0. And this is the equation where I have y equals x squared. So it's this one. So it's going to open up or down because p is less than 0. This is going to open down. Okay, perfect. So let's find the vertex now. Maybe I can squeeze it in here. The vertex would be, again, XY coordinate, opposite side of the 1, opposite value of the -1, which is 1, opposite value of -3, which is 3. So my vertex is 1, 3. Okay, so I'm going to erase this. And I am going to draw the curve just as a guide. So, and I'm going to position the vertex at 1, 3. So here is 1, and let's say that this is 3. Okay. And this curve is going to, because P is less than 0, open out. So this is 1, 3. The curve is going to open down. Now, the focus and the directrix is going to be the opposite side where the parabola opens. So my directrix is going to be here. And because it is parallel to the x, the equation is going to be y equals some number. Now, this distance from the vertex to the directrix is p units. So the absolute value of p, right? So p is -4, but in absolute terms, it's 4. So I go above 4 units from my location, which is the y value of 3. So this is y equals 7. And Professor, why are you not picking the 1 instead of the 3? Well, because this is in the y direction, right? I'm moving up and down in the y, so the value that changes is the y, not the x. Okay? Now, and same goes for the focus. So the focus, I have to go 4 units from my current location 3, right? So 3 minus 4, I get to -1. So here is my focus, which is x1 and -1. Okay, 4 units below this value. So now I have everything. I have the vertex, I have the directrix equation, don't write the 7, only y equals 7, and the focus, which is 1, -1. Okay? So these are the only 2 types of questions that you can get on an exam. So I'm very unlikely give you the parabola position at the origin. So you're either going to get an equation that looks like this, or this, obviously, or so that you have to complete the square, like example 5 and example B right here. So this is the only thing that you're responsible for that we're going to cover. And all that you have to do is put the equation in standard form, find the vertex, find the directrix, and then find the focus.